From the very beginning of civilization, humans have asked questions that stretch beyond survival. What is out there? Why are we here? How does the world work? We've built tools, theories, and entire sciences in pursuit of these questions. Yet, as far as we've come, there's always been a nagging doubt. Are there limits to what we can ever know? It's a question that haunts both scientists and philosophers. And it's not just about lacking resources or technology. It's about whether reality itself places unbreakable barriers around human understanding. One of the most famous of these barriers is written into the very equations of quantum physics, the Heisenberg uncertainty principle. But before we get there, let's take a step back and see how humanity has wrestled with the limits of knowledge throughout history. Long before telescopes, microscopes, and particle accelerators, humans looked at the stars and wondered. Ancient civilizations built myths to explain lightning, seasons, and the movements of celestial bodies. The Egyptians tracked the Nile floods, the Babylonians charted the heavens, and the Greeks debated whether knowledge was even possible at all. Socrates famously said, "The only true wisdom is in knowing you know nothing." It wasn't defeatist, it was a reminder that knowledge is never complete. Every discovery uncovers more mysteries. For example, when Newton described gravity, it felt like the final word on motion. But centuries later, Einstein revealed that space and time themselves bend and curve, and suddenly the final word was rewritten. The history of science is, in many ways, the history of limits being pushed back. But no matter how far we go, there's always a horizon waiting ahead. The question is that horizon infinite, or do we eventually hit a wall? Before diving into physics, we need to clarify, what exactly do we mean when we say knowledge? Is it just information, facts we can memorize? Or is it something deeper, understanding the why behind the facts? Philosophers call this the problem of epistemology, the study of knowledge itself. For example, you might know that the Earth orbits the Sun, but do you know why it does? Do you understand the invisible gravitational interactions, or just the statement of fact? Knowledge has layers. Descriptive knowledge, knowing the what. Explanatory knowledge, knowing the why. Predictive knowledge, knowing the what will happen next. The deeper you go, the more fragile certainty becomes. The Heisenberg uncertainty principle isn't just about fuzzy math. It's about showing us that even perfect knowledge has limits. That's where our journey now heads. In 1927, a young German physicist named Werner Heisenberg published an idea so radical that even Einstein himself struggled to accept it. It wasn't about strange particles or new forces. It was about the very act of knowing. Heisenberg discovered that at the quantum level, there are fundamental limits on what we can measure. Specifically, if you measure a particle's position very precisely, you lose accuracy in knowing its momentum, its speed and direction. If you measure its momentum precisely, you lose accuracy in knowing where it actually is. The deeper truth is this: the act of observation itself interferes with reality at the quantum level. In other words, there's a fundamental blur baked into the universe. It's not about bad microscopes. It's about nature saying, this much you can know, but no further. This single principle shook science to its core. For centuries, scientists assumed that if you had a powerful enough instrument, you could, in theory, know everything about the world. Heisenberg shattered that dream. He revealed that knowledge has a quantum ceiling. To understand just how shocking this was, let's compare it to the world we see every day, the classical world. In classical physics, the physics of Newton, planets, and falling apples, you can, in principle, know everything. If you know the exact position and momentum of every particle, you can predict the future and retrodict the past with perfect precision. This is sometimes called Laplace's demon, after the French mathematician Pierre-Simon Laplace. He imagined a super intelligence that, if it knew the current state of the universe, could calculate everything, past, present, and future. Total knowledge, total certainty. Now, enter quantum mechanics. Suddenly, this neat picture collapses. The uncertainty principle makes Laplace's demon impossible. You cannot have total information even in theory. And quantum mechanics doesn't stop there. It introduces ideas like wave-particle duality, particles acting like both waves and particles; superposition, a particle being in multiple states until observed; and entanglement, particles linked across space in ways Einstein called spooky. In this strange realm, the certainty of classical physics dissolves into probabilities. Instead of saying, this is where the electron is, physicists must say, there's a 60% chance it's here, a 30% chance it's there, and a 10% chance it's somewhere else. Reality becomes a game of dice, not of clockwork gears. Einstein hated this idea. He famously declared, God does not play dice with the universe. But as decades of experiments have confirmed, dice seem to be exactly what nature plays with. The Heisenberg uncertainty principle sits at the heart of this new quantum reality. It's not just a mathematical rule. It's a statement that the universe itself is built on limits. Let's take this further. The uncertainty principle doesn't just tell us about electrons, it tells us something profound about observation itself. Every time we try to measure the world, we interact with it. Looking, probing, recording, these are not passive acts. They leave fingerprints on the system we're trying to observe. At the everyday human scale, those fingerprints are too small to matter, but at the quantum scale, they define what is possible to know. Think of it like this. Imagine trying to measure the temperature of a cup of coffee. If you dip a thermometer into it, the thermometer absorbs some heat, slightly cooling the coffee. On our scale, this effect is negligible, but in quantum mechanics, there is no negligible. Every act of measurement changes the system fundamentally. This forces us to confront an uncomfortable truth. The observer is always part of the equation. We cannot peel ourselves out of reality and look at it from a perfect, detached distance. Knowledge is not just about what's out there, it's about how we interact with what's out there. And here's the twist. These limits aren't just technical barriers, they're philosophical ones too. If there's a built-in fuzziness to reality, then human knowledge will always have blind spots. There are truths about the universe that might exist, but we will never be able to pin them down with absolute precision. Some scientists find this frustrating, even maddening. Others find it beautiful, that reality preserves a kind of mystery no matter how deep we dig. This choice affects pacing. One way we build slowly but richly, the other way we get the full skeleton first. The Heisenberg uncertainty principle is not just a scientific rule. It's a philosophical earthquake. For centuries, philosophers dreamed of certainty. From Descartes declaring, "I think, therefore I am," to scientists chasing ultimate laws, the human mind has always sought firm ground. But quantum mechanics whispers something different. It says, certainty may not exist at the deepest level of reality. Think about that for a moment. If we can never fully know both position and momentum, what does that mean about reality itself? Is the universe indeterminate, unfolding in ways that even the laws of physics cannot fully predict? Or is it simply hidden from us, with secret layers beyond our reach? This raises timeless questions. Do we shape reality by observing it? Is knowledge an endless pursuit, or are we chasing something that can never be fully caught? If there are limits to what we can know, does that mean there are truths forever outside human grasp? Some philosophers argue that the uncertainty principle proves we live in a probabilistic universe, a cosmos where chance, not certainty, rules the game. Others argue it's a lesson in humility, a reminder that human beings are not the masters of truth, but explorers within it. It's almost poetic. The deeper we dive into reality, the more it slips through our fingers. And maybe, just maybe, that mystery is what keeps the universe endlessly fascinating. This question has haunted thinkers for centuries. Is total knowledge even possible? At first, science seemed to say yes. Every mystery solved felt like another step toward a complete picture. Newton unlocked gravity. Maxwell revealed the secrets of electricity and magnetism. Darwin explained evolution. Each discovery seemed like a puzzle piece snapping into place. But with the arrival of quantum mechanics, the puzzle itself began to blur. Instead of a crisp picture, we found probabilities, uncertainties, and fundamental gaps. So, can we ever know everything? Here are a few perspectives. The optimist's view. Perhaps knowledge is infinite, but also endlessly expanding. Each generation learns more, and while we may never reach the end, we can keep getting closer. The realist's view. There may be hard boundaries. Just as the uncertainty principle blocks complete precision, there may be truths about reality we'll simply never access. For example, what lies beyond the edge of the observable universe? What happens before the Big Bang? The philosopher's view. Maybe asking, can we know everything, is like asking, can a fish understand the ocean? Knowledge may be bound by the very structure of our minds, just as fish are bound by water. And yet there's beauty in that. If we could know everything, curiosity would die. The very fact that there are limits means there will always be something more to wonder about, to reach for, to imagine. So perhaps the answer isn't yes or no. Perhaps the answer is, we will know more, always more, but never all. And that might be exactly how it's meant to be. If uncertainty defines the quantum world, then what about the cosmos itself? The very largest scales of existence also confront us with limits. For one, the observable universe is bounded. Light has only had about 13.8 billion years to travel since the Big Bang. That means we can only see as far as light has had time to reach us. Beyond that, it's forever hidden. There might be galaxies, structures, even whole cosmic realms, but their light will never arrive. That's a boundary of knowledge no telescope can cross. Then there's the mystery of dark matter and dark energy. Together, they make up about 95% of the universe's contents, yet we don't truly know what they are. We only know they exist because of their effects. The way galaxies spin, the way the cosmos expands. Imagine reading a book where 19 out of 20 pages are missing. That's how little we know of the universe's true nature. And at the edge of physics lies an even stranger mystery, the unification problem. Our best theories, quantum mechanics for the very small and general relativity for the very large, don't fully agree. At black holes or at the beginning of the universe, the two clash. Somewhere, there must be a deeper theory tying them together. But for now, it's out of reach. So, whether we look at the tiniest particles or the vastest galaxies, we find limits. Knowledge stretches far, but horizons always loom. The uncertainty principle reminds us that at the heart of reality lies a veil, sometimes thin, sometimes impenetrable, but always there. Science and philosophy might seem like separate worlds today, but they actually grew up as siblings. In ancient Greece, there was no hard line. Philosophers were also scientists, and scientists were philosophers. They asked the same question in different forms. What can we know, and how can we know it? The Heisenberg uncertainty principle reawakens this old dialogue. It blurs the border between physics and philosophy. On one hand, it's a precise mathematical rule. On the other, it whispers about the limits of human knowledge itself. Philosophers ask, does uncertainty mean reality itself is fuzzy? Or does it only mean our descriptions are fuzzy? Is the universe probabilistic, or are we simply too small to see the underlying clockwork? Scientists, meanwhile, test the principle again and again, and every experiment so far confirms it. The math works, the predictions match reality, and yet, what it means is still up for debate. This is where science and philosophy meet, in the space between data and meaning. Science gives us the equations, philosophy asks what they imply. Together, they remind us that knowledge is not just about facts, it's about interpretation, perspective, and humility. And perhaps, in the gentle hush of uncertainty, philosophy and science can walk hand in hand once more. So far, we've talked about physics, measurement, and the vast universe. But let's bring this closer to home. What does the uncertainty principle and the idea of limits mean for us as human beings? We live in a culture that often craves certainty. We want answers, predictions, guarantees. We ask doctors for exact outcomes, leaders for clear directions, technology for perfect solutions. But life, much like quantum mechanics, resists absolute certainty. Uncertainty is woven into our daily existence. We don't know what tomorrow will bring. We can't know every thought in another person's mind. We can't predict every twist of chance, every accident, every discovery. The Heisenberg uncertainty principle becomes a metaphor for life itself. Just as we cannot know both position and momentum with infinite precision, we cannot know the exact future while standing firmly in the present. The act of living, of observing, of choosing, changes the path ahead. And maybe that's not something to fear. Maybe it's something to embrace. Uncertainty leaves room for surprise, creativity, and growth. It means the story is never fully written, that there are always new pages waiting to unfold. Instead of seeing uncertainty as a flaw in the fabric of life, perhaps we can see it as a gift, a reminder that mystery still exists, that the unknown is what keeps life vibrant. If knowledge has limits, can new tools push those boundaries further? Today, humanity is building technologies that sound almost like science fiction. Artificial intelligence is reshaping how we process information, uncover patterns, and even generate insights once hidden to human minds. Quantum computers, still in their infancy, promise to solve problems classical computers could never touch, using the very uncertainty of quantum mechanics as their strength. But here's the paradox. Even these tools may not break the fundamental limits. They can extend our reach, deepen our maps of reality, but they cannot erase the uncertainty principle. They cannot give us total certainty where none exists. Imagine it like exploring an endless coastline. Our ships are getting faster, our maps more detailed, but the horizon always moves ahead. AI may help us recognize patterns we could never see. Quantum computing may simulate realities we could never calculate. But the horizon of knowledge, the boundary between what can be known and what is forever hidden, will always remain. And perhaps that's okay, for the story of human knowledge has never been about reaching the end. It has always been about the journey, the restless, beautiful urge to learn, to discover, to stretch into the unknown. If the uncertainty principle draws boundaries around what we can know, then the final frontier of understanding is not just out in the stars or inside atoms. It's right at that boundary. Imagine standing at the edge of an ocean at night. The waves lap at your feet, the horizon stretches beyond your sight, and you know there's more out there than you will ever explore. That is where human knowledge stands. We dip our toes into the infinite, mapping little islands of certainty in a vast sea of mystery. At this frontier, we encounter questions that may never have final answers. What caused the Big Bang? Is there something beyond the observable universe? Is consciousness a physical process or something more? Do hidden dimensions or parallel realities exist? Each question is like a door.
half open, inviting us in, but always receding as we approach. The uncertainty principle reminds us that some doors may never fully open, and yet we keep walking because the pursuit itself gives meaning. This final frontier is not just about physics. It's about the limits of human imagination, the courage to live with mystery, and the humility to accept that not knowing is part of existence. There's something poetic about limits. Without them, the universe might feel flat and predictable. With them, the universe breathes mystery like a heartbeat pulsing through reality. Think of a piece of music. If you knew every note ahead of time, there would be no beauty in listening. The pleasure comes from uncertainty, from not knowing what comes next. Life and knowledge work the same way. The Heisenberg uncertainty principle is like a cosmic reminder that surprise is built into the fabric of existence. The universe is not a lifeless equation, solved once and for all. It is alive with uncertainty, with possibility, with mystery. Mystery is not the absence of knowledge, it is the invitation to wonder. It is the space where curiosity blooms, where imagination stretches, where science and art meet. If we could know everything, wonder itself would die. Perhaps that's why the universe protects its secrets so carefully. Perhaps mystery is not an obstacle to knowledge, but the very thing that gives it meaning.
This final frontier is not just about physics. It's about the limits of human imagination, the courage to live with mystery, and the humility to accept that not knowing is part of existence. There's something poetic about limits. Without them, the universe might feel flat and predictable. With them, the universe breathes mystery, like a heartbeat pulsing through reality. Think of a piece of music. If you knew every note ahead of time, there would be no beauty in listening. The pleasure comes from uncertainty, from not knowing what comes next. Life and knowledge work the same way. The Heisenberg uncertainty principle is like a cosmic reminder that surprise is built into the fabric of existence. The universe is not a lifeless equation, solved once and for all. It is alive with uncertainty, with possibility, with mystery. Mystery is not the absence of knowledge. It is the invitation to wonder. It is the space where curiosity blooms, where imagination stretches, where science and art meet. If we could know everything, wonder itself would die. Perhaps that's why the universe protects its secrets so carefully. Perhaps mystery is not an obstacle to knowledge, but the very thing that gives it meaning. As we bring these ideas closer to daily life, there is a quiet lesson hidden in all this. The lesson is not just about electrons or galaxies, it is about how to live. Uncertainty is not just in physics, it's in every choice we make. We don't know if a decision will lead to success or failure. We don't know how relationships will unfold or where life's path will bend. We live inside the uncertainty principle every day, though we rarely name it. To live with uncertainty is to live with courage, to say, I do not know, and that is okay. To take a step, even when the road is foggy. To embrace the unknown, not as an enemy, but as a companion. There is a kind of peace in that. Just as physicists learn to accept that not everything can be measured at once, we too can learn to rest in the knowledge that not everything must be certain. The gentle art of living with uncertainty is simply this: to replace fear with curiosity, to replace the demand for control with the wonder of discovery, to trust that even in the blur, life carries us forward. And perhaps, just as in quantum mechanics, the blur is not a flaw in the design, it is the design. If uncertainty shapes matter and energy, could it also shape something as slippery as time? Physics tells us time is not absolute. It bends with gravity, it stretches with speed. To us, it feels like a steady river, but in truth, it's more like a fabric, stretched and warped by the cosmos. Now add uncertainty into the mix. We know the present moment only dimly. The past exists in memory, often blurred and imperfect. The future is a horizon we can never fully see.
In a way, human life mirrors the uncertainty principle. The more we firmly hold on to the past, the less clearly we see the future. The more we fixate on the future, the less present we are in the now. Memory itself is uncertain. We think of it as a recording, but neuroscientists know it is more like a painting, retouched, reimagined, and sometimes rewritten each time we recall it. So just as physicists must accept that perfect precision is impossible, perhaps we too must accept that our experience of time will always be uncertain, shaped by memory, expectation, and imagination. And maybe that's part of the beauty. Time is not a rigid clockwork, but a living mystery. One of the most haunting questions raised by the uncertainty principle is the role of the observer. In quantum mechanics, observation is not passive. It affects what is being observed. A particle is not in a definite state until it is measured. This sparks a provocative thought. Does consciousness play a role in shaping reality? Physicists debate this fiercely. Some argue observation is just interaction. The measuring device itself collapses the quantum wave. Others suggest that awareness may be tied in some unknown way to the unfolding of reality. This doesn't mean mind creates matter, but it does leave us with an eerie question. If the universe requires observers for certain outcomes, then what is the true relationship between mind and cosmos? Even without diving into speculation, we can say this much. Uncertainty reveals that knowledge is never separate from the knower. We are woven into the fabric of the universe, not outside of it. Consciousness is not a detached spectator, but a participant in the unfolding drama of existence. And maybe that's why mystery touches us so deeply, because it's not out there, it's also in us. If life and physics are both steeped in uncertainty, then why do we see so much order in the world? Why do planets trace predictable orbits? Why do seasons return? Why do patterns emerge from chaos? This is one of the paradoxes of the universe. Certainty and uncertainty coexist. At the deepest level, particles flicker with probability, but at larger scales, patterns emerge. Electrons might be uncertain, but atoms form reliably. Atoms might be uncertain, but stars burn steadily. This emergence of order from uncertainty is what allows life itself to exist. Too much chaos and nothing holds together. Too much rigidity and nothing can grow. The universe balances on the edge, letting patterns blossom out of fog. We see this in our lives as well. The future is uncertain, but we still find rhythms: work and rest, growth and loss, love and change. Patterns don't erase uncertainty, they dance with it. The uncertainty principle, then, is not a statement of despair. It's a reminder that uncertainty and order are partners, shaping a universe that is both knowable and mysterious. Steady yet surprising. No matter how far we reach, there will always be horizons. The horizon is not an ending, it is an invitation. Think of standing in a desert at sunset. The sky stretches endlessly, glowing in colors you can't quite name. You walk, but the horizon never comes closer. That is what the unknown is like. Every answer we discover moves the horizon forward, opening up new questions we couldn't even imagine before. In science, we once thought the atom was the smallest building block. Then we split it open and found protons, neutrons, and electrons. We thought those were final, but then came quarks, gluons, and fields. With each breakthrough, the horizon moves again. The uncertainty principle tells us that horizons are not just practical, they may be fundamental. Some things will forever shimmer just beyond reach. But rather than despair, we can learn to see horizons as a promise. There will always be more to explore. If certainty is limited, then, how do we live with the unknown? The answer may lie in wonder. Wonder is not the same as knowing. It is the awe that rises when we meet what we cannot fully grasp. It is what a child feels looking at the stars, or what an astronomer feels peering through a telescope.
It is a quiet mix of curiosity and humility, a recognition that the universe is vast and we are small, but connected to it. In a way, wonder is its own form of knowledge, not the knowledge of equations or precise predictions, but the knowledge of experience, of feeling, of being alive within mystery. The uncertainty principle could be seen as a boundary, but it could also be seen as a doorway to wonder. By telling us there are limits, it invites us into the beauty of what lies beyond. Without wonder, knowledge becomes dry. With wonder, even limits become luminous. There's a stillness at the edge of understanding. When we accept that not everything can be known, something soft opens within us. A peace, almost. Physicists searching for certainty find instead a quiet infinite, a reality woven from probabilities, horizons, and mysteries. Philosophers chasing truth find not a final word, but endless questions, and we, in our daily lives, discover that the unknown walks beside us, yet it doesn't have to frighten us. The uncertainty principle reminds us the universe is not a closed book. It is a story still being written, a story with infinite twists, infinite chapters, infinite spaces left blank. And maybe the blank spaces are not flaws in the story, maybe they are the places where imagination, curiosity, and wonder breathe. The quiet infinite is where science, philosophy, and human life all meet. It is the gentle recognition that while we cannot know everything, we can live beautifully within the mystery. Life often unfolds in the space between certainty and mystery. We know some things. We can predict the sunrise, measure the seasons, map the stars, but just as often we find ourselves in the mist, facing questions without clear answers, moments without clear outcomes. Science reflects this balance. The laws of physics give us order, planets orbit, atoms bond, light bends. And yet, within those very laws, uncertainty lingers. Electrons blur, measurements fuzz, probabilities replace absolutes. Maybe this is the universe's gentle reminder: too much certainty would make life rigid, mechanical. Too much mystery would make it chaotic, unlivable. But in the middle, between order and uncertainty, life becomes possible. Stars burn, rivers flow, people dream. We live always on that line between the known and the unknown, and maybe that's exactly where we're meant to be. There's a kind of poetry in the idea that limits are not barriers, but shapes. A river needs its banks to flow. Music needs silence between the notes. A painting needs edges to hold its colors. In the same way, the limits of knowledge shape our experience of reality. If everything could be known perfectly, the universe would be a solved puzzle, complete, finished, static. But because there are limits, the puzzle is always changing, always expanding, always inviting us deeper. Even Heisenberg himself once wrote that what we observe is not nature itself, but nature exposed to our questioning. Knowledge is always framed, always bounded, and within those bounds, meaning emerges. The poetry of limits is that they are not the end of wonder, but the beginning of it. Like a horizon glowing at dusk, limits do not close the world, they light it with mystery. If we step back, we might see the uncertainty principle not as a wall, but as a breath. Inhale, exhale. Knowing, not knowing. Certainty, uncertainty. The universe itself seems to breathe this way. Stars collapse and explode, galaxies form and fade, atoms flicker between states. Patterns appear, dissolve, and reappear. The cosmos is not a machine ticking away. It is alive with motion, rhythm, and flow. To live with uncertainty, then, is to breathe with the universe, to let go of the need for perfect answers and instead rest in the rhythm of discovery. Each question answered opens another. Each horizon crossed reveals a new one. And in this breathing, we find peace. Knowledge is not a final destination.
It is a journey, a pulse, a flow that carries us forward. The universe breathes, and so do we, together in the endless mystery.
Everywhere we look, we crave certainty. We want clear answers, fixed truths, solid ground beneath our feet. Yet the deeper we explore, the more we discover that certainty often casts a shadow. The shadow is not darkness, it is possibility. When you cannot know exactly where a particle is, it might be anywhere. When you cannot predict precisely how life will unfold, countless paths remain open. Shadows remind us that the world is not fully mapped. There are corners left to wander, mysteries still alive. If knowledge were complete, there would be no room for discovery. But because shadows remain, curiosity endures. The uncertainty principle teaches us that even the smallest particles cast these shadows of possibility, and through them, reality itself stays open, flexible, alive. Imagine standing in a quiet concert hall. The lights are dim, the audience hushed. A violinist lifts the bow, and in the silence before the first note, endless possibilities hang in the air. This is what probability feels like. It is not emptiness, it is potential. 1,000 notes could be played, but one will emerge. Quantum mechanics hums with this music. Particles exist in states of probability until measured. The uncertainty principle doesn't silence the music. It ensures that the song of the universe is never fully written in advance. Life, too, is composed this way. The future is not fixed, but probabilistic. Each choice, each moment shifts the melody. We don't hear the whole song at once. We hear it unfold, note by note, possibility by possibility. In this sense, the uncertainty principle is not chaos. It is music. A music that never ends, always improvising, always alive. There is a kind of ignorance that is harsh, the refusal to learn, the denial of truth. But there is also a gentle kind of ignorance, one born from humility. It is the recognition that not everything can be known, and that's all right. Gentle ignorance softens the mind. It allows wonder to grow. It lets us listen instead of forcing answers. It's the openness a poet feels under the stars, or a scientist feels when data resists explanation. The uncertainty principle invites us into this kind of gentle ignorance, not the ignorance of neglect, but the ignorance of awe. We are not meant to have every answer. We are meant to walk among the questions, to let them guide us, to find beauty in the spaces where certainty dissolves. And in that space, strangely, we often feel most alive. Every civilization has searched for ways to speak about the unknown. Some used myths and legends, others used mathematics and equations. Today, we have the language of quantum physics. But even this language, as precise as it is, carries silence between its words. The uncertainty principle is not just the law of physics, it is a whisper that tells us reality resists complete translation. There will always be truths that slip between symbols, always mysteries that numbers can only point toward but never fully capture. The unknown has its own language. It speaks in silence, in wonder, in the pause before understanding. If we listen closely, we may hear not confusion, but invitation. When we look into the universe, we are also looking into a mirror. The questions we ask reveal the shape of our minds. We seek certainty because we long for safety. We discover uncertainty because reality reflects our own limits back to us. The uncertainty principle is not just about particles, it is about perception itself.
Our minds crave clarity, yet they also thrive on mystery. Too much certainty and curiosity fades. Too much uncertainty and we lose our footing. The balance we find in physics is the same balance we live in daily life. Enough structure to move forward, enough mystery to keep exploring. In this way, the uncertainty principle is not just science. It is psychology, philosophy, even poetry. It is a mirror held up to our search for meaning. We often think of truth as something whole, complete, final. But perhaps the most beautiful truths are the incomplete ones. A half-remembered melody still stirs emotion. A poem with unanswered questions lingers longer in the mind. A painting with blurred edges draws the eye deeper than one that is too sharp. In the same way, the uncertainty principle gives us an incomplete truth, not because we have failed, but because the universe itself is shaped that way. Some things can never be pinned down. Some truths are forever in motion. And maybe that's what makes them beautiful. An incomplete truth leaves space for imagination, for curiosity, for wonder. It keeps us alive to possibility, awake to mystery, and open to the quiet infinite.
Our senses give us the world, but always through a veil. Eyes translate light into shapes and colors. Ears weave vibrations into sound. The mind interprets, filters, organizes, and in doing so, it hides as much as it reveals. The uncertainty principle reminds us that even with our best instruments, even with microscopes and particle colliders, there is always a veil. Reality at its finest scales will never show itself naked. It will shimmer, blur, remain partly hidden. But maybe this veil is not a flaw. It is part of the design. Too much clarity might leave no room for imagination. A perfectly sharp universe would feel lifeless. Instead, the veil leaves mystery alive. We don't see everything, and that very not seeing is what makes seeing so precious. Every answer is followed by a new question. This is the rhythm of knowledge, the heartbeat of discovery. When Heisenberg introduced his principle, it wasn't the end of physics, it was the beginning of quantum mechanics, a field that reshaped science, technology, and philosophy forever. But even quantum mechanics is not the end. It opens new puzzles. What is reality made of? Do hidden variables exist? Does consciousness play a role? Questions without end are not failures, they are fuel. Each one keeps the story going. Each one turns the page to a new chapter. The uncertainty principle is one of those eternal questions, not something to be solved once and for all, but something to live with, to wrestle with, to be guided by. Like a star that never stops shining, it lights the path without ever being reached. Infinity is not always vast and overwhelming. Sometimes it is gentle, like the endless ripples on a quiet lake. The uncertainty principle hints at this kind of infinity. Within the smallest scales of reality, there are endless possibilities, endless probabilities, endless variations. Each particle could be here or there, this or that. And in their dance, infinity is expressed not as immensity, but as subtle variation. To contemplate this is calming. We are not trapped in a rigid world. We are carried in a gentle infinity, one that surrounds us like a soft horizon, one that whispers that life itself is woven from unending mystery. This infinity does not shout. It breathes quietly, like the universe itself. And when we rest in that breath, we feel a part of something endless.
Not all horizons lie in the outer universe. Some are within us. There are limits to what we can remember, to what we can feel, to what we can fully explain even about our own minds. Just as the uncertainty principle tells us that particles cannot be pinned down, our inner world also resists being fully measured. Dreams slip away when we wake, memories shift as we recall them, emotions rise and fade without warning. We are, in many ways, our own quantum mysteries. This realization can be comforting. We don't need to have ourselves fully figured out. Like the cosmos, our inner lives are meant to remain partly unknown, always unfolding, always shimmering just out of reach. For centuries, humanity has tried to push back the darkness of mystery with the light of knowledge. And we've succeeded. We've discovered galaxies, decoded DNA, split the atom, walked on the moon. And yet, mystery remains. It always will. The comfort of the uncertainty principle is that it tells us this is not failure. This is design. Reality itself is built with spaces that will always remain soft, indeterminate, ungraspable. Instead of fearing the mystery, we can rest in it. Like night following day, it is part of the balance of existence. Without mystery, life would lose its depth. Without mystery, wonder would fade. Mystery is not an obstacle, it is the gentle rhythm that makes the universe sing.
And so, as we reach the end of this long journey, we return to the simple truth. Knowledge has limits. The universe has horizons. The uncertainty principle reminds us that even in the tiniest corners of existence, mystery endures. But far from being a defeat, this is a gift, because mystery keeps life open. It keeps curiosity alive. It keeps wonder glowing. We may never know everything. We may never capture every answer. But we can live beautifully with the questions. We can rest in the quiet infinite, knowing that uncertainty is not emptiness, it is possibility. So let us leave tonight with peace, carried by the thought that the universe is not meant to be solved, but lived within. Each mystery, each uncertainty, is a doorway, and behind every doorway is wonder. Goodbye, dreamer. May you drift gently into rest, carried by the endless mystery of the cosmos.